we're going to take a look here at the benefits of a series circuit or the benefits of a parallel circuit, depending on what you're trying to do. So in this circuit, what I have is I have my batteries over here. These are two 1.5 volt AA batteries. I have a switch connected to a light bulb here, and then another switch connected to a motor here. So this circuit is set up in parallel. And the reason for that is if I want to control two things in one entire circuit, but I want to be able to control them independently of each other, then I want to have a parallel circuit. So this could be something like if you were controlling a drone that had maybe a motor and then a light on it, because you don't necessarily need to run the light during the daytime. Maybe you'll need to run the light at night, or maybe you don't want to run the motor, you just need the light on for some reason. This way it allows us to have one circuit, one set of batteries, and then different controllers throughout the circuit depending on what we're trying to do. So the benefit of this is that I can turn the light on or off, and I can turn the motor on or off, or I can have them both on at the same time. This allows me to control them independently, and one is not necessarily reliant on the other. So what that means is if my motor fails for some reason, it breaks or it needs to be repaired or whatever, I know that it's not a bigger problem because my light still works. If both my motor and my light didn't work, well, then I wouldn't maybe have a clear idea as to what's going on, maybe replace the batteries, maybe there's a problem somewhere else in the circuit. So this allows me to troubleshoot a little bit better. If the light works and the motor doesn't, well then I know there's a problem with the motor. If the motor works and the light doesn't, I know there's a problem with the light. If neither of them are working, it typically gives me an indication that there's a problem somewhere else in the circuit causing everything to fail. I've changed my circuit now so that it's in a series configuration. So we can see that everything is kind of in one line here, so that the electrons are flowing from the batteries to the switch, to the light, to the motor, and then back again to complete the circuit. So why would anybody want to have their circuit in a series configuration? It seems like the parallel configuration is infinitely more useful. Well, there's one main benefit to having your entire circuit in a series configuration, and it's that it allows you to know when something has gone wrong. So for example here, if I turn on my circuit, I can see the light goes and the motor goes, and that's great. Now, it's hard for me to diagnose here if, say, the motor stopped running for a reason. I'm going to pull out this part of the circuit here. Well, I might originally assume that, oh man, there's something wrong with the motor. Now, the motor is going to be expensive to replace, and I don't want to necessarily jump to that conclusion right away. So with the light off, what it tells me immediately is that there's something wrong in the circuit, and it might be as simple as swapping out a battery or maybe replacing some wiring somewhere, which is usually going to be a bit of a cheaper experience for you than having to replace a motor if you're thinking of a bigger operation here. Where you can see this more often is in your home. So in your home, usually the plugs are wired up so that you don't need every plug used at the same time, right? You can have your TV on and your lights off, or your lights on and your TV off, and there's no problem. But the lights in your room are typically connected so that they will fail if the breaker in your basement goes. And what that is able to tell you is that if your TV doesn't turn on, it's not necessarily a problem with your television. You'd be much more hard-pressed to replace your TV than to go downstairs and just flip your switches in your breaker box. This allows you to kind of know that, okay, it's probably not as big of a deal. So this way, if everything's working, great, I know it's all working. But if something doesn't work, it's either because a breaker's blown and all you have to do is switch it back on, and it's probably not a problem with the motor. However, that being said, if your motor does fail, and if I removed our motor from our circuit like this, and we pretend like our motor has failed, well then of course the rest of the circuit isn't going to turn on either.
Thanks for watching. Make sure you like, get subscribed, leave a comment below, and check out our suggested videos. Make sure you hit the bell icon so you don't miss any future updates.